Hello and welcome back. We are taking a look at a couple of questions from the quiz, and here we have another very similar question to the one we just discussed. We have to find the minimum surface area of a rectangular prism box with lid that could just hold 24 cans of mango juice in stacks of 2 cans that are arranged in 3 rows of 4 stacks. Okay, too many cans and stacks in here, so I'm going to read the problem a bit more slowly to make sure that I understand it better. So we have to find the minimum surface area of a rectangular prism box with lid, which means that we're looking for the surface area of a prism. And in that box, we are storing 24 cans in total. And let's take a look at how we're arranging the cans. So the cans are of a cylindrical shape, as you can see, just like in the previous question we discussed. And they are arranged in stacks of 2 cans, which are arranged in rows, in 3 rows and 4 stacks. So what that means is that we have 24 of these cans, and we are arranging them in 2 layers. So in the first layer, we're going to have an arrangement of 4 by 3 cans, okay? And on top of it, we're going to put another layer of the same arrangement. So as you can see here, we have 12 cans, and then another 12 cans will be on top of it. So first of all, let's take a look at the measurements of this cylindrical shape. So as you can see here, we have 5 centimeters. So you see that the arrow is pointed at this length. So that makes me think that this is the diameter. And it can be a little bit confusing actually when it comes to getting the measurements from the diagram. Especially in a case like this, because it is very easy to confuse it with the radius of the base. But the way that I see it, or the way I understand it, is this. So since I am given the whole line in here and the 5 centimeters is pointing at it, that means that that's the diameter. If I were given the radius, 5 centimeters, so the diagram would have only highlighted or drawn the line for the radius. Okay, so but totally understandable. Like I notice very often people confuse that, and the truth of the matter is that it does leave a lot of room for interpretation for sure. And then the height is 95 millimeters. Now we have to be very careful with the unit measurements. We have centimeters and millimeters where if they are working together, they have to be in the same terms. So that means that we either convert this to centimeters, to millimeters, or the millimeters to centimeters. So I choose to let the height be in centimeters here, 9.5 centimeters. And I would leave the diameter here equal to 5 centimeters. So let's take another look at the box that we're making. So our box will measure, let's take a look. So from here to here, we're gonna have 5, 5, 5, 5, 4 of them. That's 20 centimeters for the length. So the box must have a length of 20 centimeters. And let's take a look now at this, the width. And as you can see in here, we have 5, 5, 5, so 15. And I'm going to draw the base that measures 20 by 15. And I'm going to draw a box, actually, in the meantime. I know I can do a better job here. Here we go. All right, so this is how I like to draw a box. It's kind of easy. So you just put them on top of each other. When the box has a greater height, then I make sure that this overlapping area is smaller. It makes the box look taller. Okay, Here we are. And now let's take a look at the measurements. So the measurements are 20 centimeters for the length, 15 for the width, and the height in here. Remember that we will accommodate 2 layers or 2 stacks of height 9.5 centimeters each, which will make the height equal to double of 9.5, which is 19 centimeters. So that would be the height, and the width we said is 15. And here we go. Oops, that wasn't supposed to happen. So here we go, 20 centimeters. Okay, so let's find the surface area now. So it's a rectangular base prism. So the surface area would equal double of length times width times height, and width times length times height. Substitute. So for length we have 20, for width we have 15. For width we have 15, for height we have 19. For length we have 20, and for height 19. And all we have to do is evaluate. And I'm using my calculator right now, so 20 times 15 plus 15 times 19 plus 20 times 19. I'm just doing the brackets first, so I got 2 times 965. You can do this in one step. And then I will double this, and I got 1,930 centimeters squared. Let's scroll down, and I'm going to look into the options. So what I see in here is 1,900, 193 centimeters squared. I got 193,000 millimeters squared and 1.9 meters squared. So I'm confused now, and I'm thinking, which one is my answer? So I will focus only on these two numbers. The reason why I want to focus on these two numbers is because at least I see the 1, the 9, and the 3. So definitely 193 centimeters squared won't be enough for the volume, because 193 with a 0 is 10 times bigger. So however, when I look at this answer, I see way too many zeros in here, so that confuses me as well. But if you notice here, we have millimeters squared, okay? And the measurements here are in centimeters squared. So if I want to compare 1,930 centimeters squared with millimeters squared, I have to convert one into the other. Now, remember that 1 millimeter is 10 centimeters. Okay, or the other way around. So we can say 1 centimeter is 10 millimeters. So 1 centimeter squared then is 100 millimeters squared. So if I want to convert 1 centimeter squared into a millimeter squared, then I have to multiply it by 100. So convert to millimeters squared, which means that we have to multiply 1,930 centimeters by 100, and that will give 1,930 with 2 zeros, which is exactly what you see in here, and this would be the correct option to choose. Okay, so I hope that this makes sense again, and let me know if you have any questions. I'd love to hear from you. Thanks and bye for now.